For this example, we are going to use synthetic substitution, which is just like synthetic division, except we use our final answer in a slightly different way. We have a polynomial here, so they're using capital P of x for polynomial instead of f of x, but that's still basically just a y equals. And we are going to evaluate for x is equal to 2. So I'm going to set up my synthetic division using the values from my polynomial. We have a 3x cubed, 4x squared. We don't have any x's, and then we have a constant term of minus 10. I did put a 0 in for the x terms that we are missing. And then out here in front, what we are going to divide by is actually the number 2. Usually when you do synthetic division, you're dividing by a polynomial, x plus a number or x minus a number, which you would set equal to 0 and then solve. This is already solved for x is equal to 2, so we just use the number 2 out in front. When I do my synthetic substitution, it's just like synthetic division, so I'm going to do 3 plus nothing, which is 3. 2 times 3 is 6. 4 plus 6 is 10. 2 times 10 is 20. 0 plus 20 is 20. 2 times 20 is 40. And negative 10 plus 40 is 30. The last number is our remainder. The numbers in front of that are our quotient. When you do synthetic substitution, your answer is simply the remainder. So we could say that P of 2, we took 2 and we plugged it in for x, so we're calculating P of 2. P of 2 for this problem is equal to 30. That is our final answer. It is, by the way, the same answer you would get if you took 2 and you substituted it in for the x's. If you did 3 times 2 cubed plus 4 times 2 squared minus 10, you would get 30. So synthetic substitution is another way of going through and evaluating. By that I mean plugging a number in and calculating a value. And that value ends up being the remainder. So it's another way of doing a substitution. Instead of directly substituting in, we're using synthetic division, so they do call it synthetic substitution.